So I thought we make an overview of my Newton Raphson Approximation utility app. So I made this for my AP Calc class. It's a Calc 1 topic. It's Newton's approximation, uses tangency of curves to quickly approximate roots of functions. So if you don't know what the root of a function is, basically it's whenever the function equals 0. So if we take out a grapher, which we will be using for this, if we take, for example, x minus 2 squared, you will get a root at approximately 2 minus 1. We get roots at approximately different locations. For instance, 1 over here, and whatever values over here. So this works for almost anything. If you do sine x, we get them at different values around pi, 0, etc. So essentially this finds one of the roots. Well, it can find the other ones depending on what you input as a guess. So this will make sense more after. You can see that I basically got inspired with the design from OSX. It's a little bit different, but anyways. So here we have this. We can type in values over here. Now 415 is actually a constant. So if you have the function y equals 415, it would never be a solution. So if you put y equals 2, there is no solution for this. So this would simply time out. Now if we do something like x minus 2, you'll get a value at when x equals 2. So let's turn it back on. We can do something like x minus 2. We know that when this is equal to 2, this will equal 0. So we input a guess, it's input something like 105. And here we can see the derivative of this function, what the value is, input a guess in the total number of iterations. So if you press compute, this will then calculate the total number of iterations, the root. So the root solution found, there is a root at x equals 2. So it took a total number of 3 iterations in the process to get 2.0000. We can see that the derivative is slightly off, 1.000018. However, it's close enough, and the total root is just perfect. So this can do several more complicated expressions. Let's do something more complicated. We can do 3 times x minus 2 minus 2 plus 2 minus 5. Let's mess it up with that. So let's graph this, see what happens. If there's any roots, x minus 2 plus 2 minus 5. We get a root around there. So let's go back with this thing. Seems like my Mac is really glitching out. I don't know what's happening with it. But anyways, for its equals, let's enter a guess. Like 15. Guess is 15, derivative is 2.9982, which makes sense because it's 3 like that. I used string formatting to ensure that this doesn't overflow. We can then compute this, see how many total iterations it takes. Click this several times because my Mac is acting up today. At x equals 3, which makes sense. Let's see, 3. So it becomes 3 times 1, which is 3, minus 3, which is 0. Total number of iterations is 2. Okay, now we can go back with this and we can try something more interesting. Let's try something like trig functions. Sine of x, let's input around 4. Says that it's an invalid, and the reason why it could be invalid is because when you have a function like this, if you're starting off Newton's approximation close to wherever the tangent of the slope is close to 0 or an infinite slope point, it will not work. So you need to enter in something that will be a better approximation, like 3. 3 is not good. 3.1 or 156. So let's press compute and see what happens. We do 156. Where does it lead us to? So Solution found that x equals 157.07963 blah 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 blah. Now notice this uses radians, so if you try to use this on your normal calculator, it will give you the wrong answer. So to convert from radians to degrees, you'd have to do divide it by 180 and multiply by pi. So if you do take out your normal calculator, take 157.07, divide by 180, multiply by pi. Oh my gosh. So 157.079 divide by 180, multiply by pi, and then you get to come up for multiply, then take the sign of that, and it gets us close to a zero number, 0.048307, blah, blah, blah. So this is fairly accurate. We can continue on and do more. This thing can basically recognize anything. We have log in it, we have hyperbolic functions. You can raise it to the power of anything you want. You can have 4 to the power of something else, like 3 for instance. There's a lot of different options you can put. Multiplication, 10, then have x plus sine of x. You can do crazy things like this. And the program automatically verifies to make sure that you have the proper bracket proportion, so you can't put any crazy inputs into it. Then you can put in a guess, and then you can compute the guess. Solution found at negative 120.1274. So this one was significantly faster. It took 22 iterations to find the root of this expression. So it really depends on what your input is and how far away it is from the guess. But if we do 9 times 5 plus 3, 10 x plus sine x, we will get negative 120.17279612. Convert that to radians, put it into your calculator, and you will get the right answer. So I hope you guys enjoyed this video, and thanks for